sound. Okay. So is this voice is audible now at least? Right, let me check. Yes. Yeah. So let me check the voice once again. Yeah, it is clear now. Yeah. So just see here what we have discussed till now. So electrochemistry, what do we mean by electrochemistry? It's the study of the study of chemical reactions which produces electricity. What it will be producing? Electricity. Okay. So now see, in these electrochemical reactions, what happens here? So it will deals with production of electricity from a spontaneous chemical reaction. It means a spontaneous chemical reaction is taking place that produces electricity. Okay, it should be a spontaneous process. And you know what type of chemical reaction it is a? It is a generally redox reaction is taking place. That spontaneous redox reaction produces electricity. Okay, now those cells which converts these chemical reactions into and produces electricity or electrical energy from that is considered as electrochemical cells. Okay, those devices which converts chemical chemical energy into electrical energy, those are considered as electrochemical cells. Okay, the next second one is electrolysis. Okay, so what do we mean by electrolysis or electrolytic cells? So these electrolytic cells are the devices which will be useful for conversion of a non-spontaneous chemical process. It means, for example, here I am taking NaCl solution. Okay, it's a salt water, right? So from this salt water, I just wanted to produce chlorine gas. What I want to produce? Chlorine gas. So this is a non-spontaneous process. We know in the nature, like if you take seawater, it will be NaCl only, no? Yes, we have lot of chloride ions in that. So now conversion of this chloride ion to chlorine we are doing here. So it is a non-spontaneous process. It means that reaction won't take place on its own. So if it is not happening on its own, if that process is not happening on its own, what do we need to do? We need to supply some electric current. Okay, electricity is supplied, so that the required amount of electricity is supplied, so that the chloride ions will be converted into chlorine gas. Okay, so this chloride ion, conversion of chloride ion to chlorine gas is an oxidation process. What I am saying? It is an oxidation process. So oxidation process takes place at anode. Okay, I will tell you during the electrolysis discussion. So now what you are seeing, chlorine gas is produced with the help of external energy, like electricity is passed here. But whereas in electrochemical cell, that reaction is taking place spontaneously and producing electricity. Here it is a non-spontaneous chemical process, so it requires energy from outside. So that's why we are passing electricity and we are making this change. Okay, now similarly we know metal metal ions, like metals, will exist in the earth crust, I mean in the ore form, right, in the minerals, ores we are saying. So now conversion of that, like generally those are metal oxides. Now the conversion of that metal oxide to metal atom we need to do here. Right now, generally if we want any metal, for example iron, how iron will be? Iron oxide forms right now. So now we require iron metal, means first of all you need to take that oxides and you need to convert into metal. But this is a non-spontaneous process. Naturally in the nature, how iron is existing? Iron oxide. It means existence of iron in iron oxide. It means conversion of iron into iron oxide is a natural process. That's why if you place any metal rods in the to a side for a long time, what happens? It will expose to moisture, then it will be slowly get rusted and converts into iron oxide form. So iron to conversion to iron oxide, that is what? Spontaneous process, naturally happening process. But conversion of iron oxide to iron will be a non-spontaneous process. It requires some energy. So what we are saying? We are passing some electricity so that an iron oxide will be converted into iron. Okay, so with the help of electricity with the help of external energy, that passing electricity, we are making this change from iron oxide to iron. Okay, so remember this. Okay, so what do we mean by electrolysis? It's a non-spontaneous process that happens with the help of electricity. Okay, like here you are seeing. Okay, you got the two difference, one is electrochemical reactions or electrochemical cells, and other one is electrolytic cells and electrolytic reactions. Okay, that's it. The next one, so both things are clear now. Now you need to study about this electrochemical cells. What is the use of electrochemical cells? I told you. So it's a device which produces electricity as a result of chemical reaction. Okay, so now what are the examples? Here we have galvanic cell and Daniell cell. Okay, now we will be taking one example cell here, chemical cell, and we will be understanding it properly. So now what is taking place here? Conversion of electrical energy into conversion of chemical energy into electrical energy. Generally in electrochemical cells there are two compartments. What I am saying, there are two compartments like anode compartment and cathode compartment we are saying. The first one here is considered as anode compartment. So in this anode compartment generally we will be taking electrolytic solution. Okay, so for example here I am taking zinc sulfate solution. So now you take a zinc rod, like here we are taking metal like electrolyte now. So what is that metal? Here we have zinc. So take respect to salt, respect to metal rod. Okay, here I am taking zinc rod here. What we are taking? Zinc rod. And in this also I am taking copper sulfate solution, and you can dip a copper rod here. So what is this now? Copper rod. Okay, so now you just connect them through a wire, and here I am placing one ammeter. Okay, or to check voltage deflection you just check here, and a key here I am adjusting a key. Okay, right. So now what happens here, just tell me. So here anode, there are two compartments I told now, one is anodic compartment, other one is cathodic compartment. Here cathode it is. Okay, always remember at anode oxidation takes place. What happens at anode? Oxidation. So at cathode reduction takes place. What happens here? Reduction takes place. Okay, so now what do we mean by oxidation here? Loss of electrons. No? So whatever the zinc rod you have taken, so this zinc rod undergoes oxidation from 0 to +2 states. Okay, 0 to +2. So 2 electrons are released here. Zinc converting into zinc metal ion. Okay, when it comes to copper here, like cathode here, so whatever the copper +2 ions are there in the solution, okay, that will be get converted into copper atom here. Okay, solid form here. Okay, so now what is happening, how this is happening, I will tell you. See, so whatever the 2 electrons are released at the zinc rod, that slowly, like they are coming like this, and they will be going from anode to cathode compartment. Okay, so this is the flow of electrons. Okay, now whenever flow of electrons are in this direction, electricity will be in opposite direction. Now if you observe, this connection is, circuit is not completely filled, it is only from one direction. We need to make it complete now. So for that completion we are using a salt bridge. What is a salt bridge? So salt bridge is a U-shaped tube filled with agar-agar solution. Agar-agar, so it means it's a jelly substance. I am saying it's a jelly substance, agar-agar. Okay, this agar-agar will be treated with electrolyte, inert electrolyte. Agar-agar treated with inert electrolyte. So what are the examples for perfect inert electrolyte here? I am saying here inert electrolyte. Okay, so the example here is KCl or ammonium nitrate, NH4NO3. This kind of inert electrolytes are taken in this test tube, in this U-shaped tube with agar-agar gel. Okay, so now what happens here? Why only this one here? Because the mobility of K plus and Cl minus will be equal. That is called transport number of cation and anion are equal. That's why we are considering this KCl, ammonium nitrate, NH4NO3 only, not any other. I mean only few selected electrolytes are there to be used here, not everything. Like NaCl you cannot use here because they do not have equal mobilities for cation and anion, like Na plus and Cl minus do not have equal mobilities. That's why we are not preferring that here. Okay, and one more thing here, what I told you, so when electrons are flowing from anode to cathode, what happens, whatever the electrons entering from anode to cathode compartments, the 2 electrons are taken by this copper plus 2 ion from this copper sulfate solution right now. So now what happening, all copper plus 2 ions converting into copper metal right now. So now what happens, all that copper metal will deposit here. So you can say copper will be getting deposited here, and if you observe, the solution will get a negative charge, sulfate ions only present here because only copper plus 2 ions are converting into copper metal. Now copper sulfate ions will remain as such now. So now if it is happening like this, if this if these are not getting neutralized, now what happens, solution will acquire negative charge. If solution is acquiring negative charge, they won't allow the passage of or entry of these electrons into the solution right now because already they have negative charge. How this negatively charged electron will come? No, right? So what happens, with the help of this salt bridge, whatever the cations we are seeing in the salt bridge will move this side, and when they are moving this side, what they will do, they will neutralize this K2 sulfate ion like negative charge. Therefore, for example, K plus ions are moving here. So 2 K plus ion means each one plus charge, and here sulfate ion. Overall it gets neutralized like that. So with the help of salt bridge we can maintain electrical neutrality. What we can maintain? Electrical neutrality. Therefore electron flow will be properly taking place. And here also if you observe, we have zinc rod right now. This zinc rod getting oxidized to zinc plus 2 ion. So here it is neutral solid form, here it is getting aqueous state, zinc plus 2 ions. Now what happening, all electrons are moving out from this anode and only positively charged zinc plus 2 ions are forming. Now here it becomes more positive now. So if it is becoming more positive, what happens, that more positive solution acquires positive charge. Why? Because zinc plus 2 ions concentration increases due to releasing of that electrons. So now here if it is becoming zinc plus 2, now what happens, this solution which is having positive charge because of zinc plus 2, now what happens, that won't allow the electrons to flow from anode to cathode right now. So it means here also we need to maintain electrical neutrality. Therefore anions from this this inert electrolyte, that is from the salt bridge, flows here and that will neutralizes this zinc plus 2 ions. Therefore overall electrical neutrality is maintained. Therefore electron will move from anode to compartment properly, and electricity flow from cathode to anode. That's it. Okay, these are the things you need to need to remember. Here now what happens, so during this cell, this is a spontaneous reaction now. So during this spontaneous reaction, it will generate electrode potential. What I am saying, it will generate electrode potential. Okay, so how much electrode potential is generated, or what is the electrode potential of this cell, standard electrode potential of the cell? It means very easy to calculate. See what is happening. So we'll discuss about this. What is happening? So here in anode compartments, zinc is converting into Zn plus 2, okay, and in cathode compartment copper plus 2 is converting into copper. So both of them are connected through a salt bridge. That salt bridge is indicated with a double slash. Okay, now here copper plus 2 ions are converting into copper. Okay, so now this is oxidation that is taking place at anode, and you know why I have used this single slash, because zinc is a solid substance. Here Zn plus 2 is a aqueous state. Okay, it means this zinc rod getting slowly the weight of zinc rod get decreased. Why weight of zinc rod get decreases? Because that zinc rod is converting into zinc ions now. It means it is slowly dissolving into the solution, I can say. Okay, therefore the weight of zinc rod here get decreases at anode. Okay, like this oxidation is taking place. Now they have different physical states now. That's when you need to represent or separate them with a single slash. Okay, double slash represents salt bridge. Again here copper plus 2 aqueous state. Copper plus 2 is an aqueous state converting into copper solid form right now. So it is a solid form. So that's why we have indicated here single slash. Okay, first write anode, salt bridge, cathode, like that. Okay, so now how do you calculate electrode potential for this cell, standard electrode potential for this cell? So now there will be, due to the due to the spontaneous conversion of zinc to zinc ion, zinc plus 2, so there will be oxidation potential here. So E naught of Zn to Zn plus 2 you can write, okay, plus now here copper plus 2 is converting into copper, now you can write E naught of copper plus 2 to copper like this, okay, that's it. Now this both half cell reaction, this is one half cell, anodic half cell, this is cathodic half cell right now. So both of them have some specific value for reduction potentials and oxidation potential. So for this zinc conversion of zinc to Zn plus 2, it has this is oxidation now. The oxidation potential for this process, for this zinc metal will be taken as plus 0.76 volt. How much it is? Plus 0.76 volt. I will tell you what is this electrode potential, how this value we are getting here, okay, let me tell you. So this one for copper it will be 0, see this is a reduction. What is this process? See, if a metal M converting into its metal ionic form like Mn plus something like this, okay. Now what happening, by losing of electrons it is converting into its positive form now. So what is this process called? Oxidation. So the potential generated during this process is called oxidation potential. If it is measured at standard conditions, you can say standard oxidation potential. What is that? Standard oxidation potential. So this is the standard oxidation potential of zinc. Whereas if you see this metal already in plus 2 form converting into metal atom like this, copper plus 2 converting into copper. So this is what number is getting reduced in, so we can say reduction. So what is the reduction potential value for this purpose? So it will be plus 0.34 volt, okay, remember. So now add them two values, add these two values, what we are going to get here? So this will be 1.1 volt, this is E naught of cell. So this much potential is generated during the reaction, okay, during in this cell I can say, and this is positive now, yes. So if E naught cell, if whatever the calculated E naught cell value standard electrode potential is positive, then you can say this cell is a spontaneous, I mean the reaction is taking place spontaneous and reaction is producing this much potential, okay, right. Is this clear? Right. If this is clear, please click on the like button, we will discuss few more things here, okay. Let me show you a few questions from EAPCET, JEE or NEET exams so that you will get more clarity on this, okay. And here what are the other things, sometimes in the exam or during some solving the questions, if you observe, they won't mention reduction values here. So what do we mean by reduction and oxidation values? You need to know this one also now. See, if I write E naught oxidation, it means there is oxidation taking place. If more is the E naught oxidation potential, if more positive E naught oxidation potential, it means that element has more tendency see to undergo oxidation. So more oxidation, standard oxidation potential value, more positive standard oxidation potential value, the species has more tendency to undergo oxidation, okay. So it means E naught oxidation potentials or E naught reduction potentials. E naught reduction means what? For example, there is a species like E naught, like there is a species like X, okay. Now X is converting into X minus. So now what is happening? X is gaining one electron and becoming anion. So can I say this is a reduction potential? Yes, this is an indication for reduction potential like this, okay. By gaining of electron, charge get decreased on that species, therefore that process is called reduction. So during this reduction, if this value is more positive, if reduction potential value is more positive, then we can say that particular species or particular element or ion having greater tendency to undergo reduction. So greater the value for reduction, greater the tendency to undergo reduction, okay. So now what is the use of these values? Yes, these values helps us to understand which element has more tendency to undergo oxidation or reduction, okay. Now one more thing, I have mentioned here standard oxidation potential, here standard reduction potential. How can we relate them? For a particular element, for a particular process, E naught oxidation will be negative of E naught reduction, okay. For example, I am saying for E naught X conversion into x minus, reduction of x to x minus is some x to x minus is some minus 1.2 volt I am saying, or plus 1.2 volt I am saying. Okay, then conversion of x minus to x, x minus to x, this will be opposite of the above process, no? So this will be minus 1.2 volt. Okay, therefore the net change for this process will be equals to 0. If it is positive, it will be negative with the same value with the opposite signs. That's it. Okay, E0 oxidation and E0 reduction are having same values but opposite signs. Now these values are very useful when you are solving questions or when you understand the chemical reactions also. Okay, let me show you some standard oxidation and reduction potential values and you will get more clarity on this. See here, what you are seeing in this table, this is an experimental data. Okay, if you observe here, what they have mentioned, this is an experimental data for different metal, ions and atoms. Okay, I will tell you, just follow for few more minutes, so you will get more clarity on this. Yeah, so look at here, what I told you. See what happening here, you can see lithium plus is converting into lithium, it means a metal ion converting into metal atom. Okay, here also calcium plus to converting into calcium atom, it means their cations getting converted into atoms, it means that number, that positive number is getting decreased, it means we are adding electron to these ions. So what is this process called? Reduction. Okay, so this is called reduction. So it is taking place as 298 Kelvin. Okay, and their ions like concentration will be taken as 1 molar. Okay, so if concentration is 1 molar, temperature at 298 Kelvin, if it is a gaseous species, maintain pressure at 1 atm, then the electrode potential measured is considered as standard electrode potential. Okay, I am saying normal electrode potential, just like electrode potential and standard electrode potential. It means a specific temperature, pressure, concentration is mentioned now, that's why I am saying it as a standard electrode potential. If no temperature, pressure, concentrations are maintained, then you can say just normal like electrode potential itself. Okay, now these values are standard electrode potential that are measured at 298 Kelvin. Okay, so now if you observe down the group, down this series, what is having here, lithium plus ion is having more negative reduction potential value. So it is more negative reduction potential value means, see for example E0 of Li plus to Li. So how much it is? Minus 3.05. Now if I say oxidation potential, how much it will be? So E0 of Li to Li plus. Now for this conversion, it will be positive now, positive 0.35. So this is oxidation potential, reduction potential. See, since lithium has strong, greater positive, like more positive oxidation potential now, so lithium like alkali metals will be losing their electron easily and they will be staying in positive oxidation, unipositive oxidation states. So I can say lithium has greater tendency to lose the electron. So if it is having greater tendency to lose the electron, that lost electron is taken by other species, that other species will undergo reduction and this is undergoing oxidation right now. So now lithium plus ion is a species which can be considered here as strong reducing agent. So lithium considered as strong reducing agent because it is undergoing, lithium is considered to be strong reducing agent. Why? Because it is undergoing oxidation and reducing other species now, therefore lithium can be considered as strongest reducing agent. Okay, so if the species has more negative reduction potential or more positive oxidation potential, you can consider that as a strong reducing agent. What I am saying? Strong reducing agent. So they will give different elements here, which are the following is an strong reducing agent, or order of the following elements in the order of their reducing nature or reducing power, oxidizing power, like this. These are the common questions from NEET as well as JEE as well as EAPCET. Okay. Now they will ask, for example, they will give these examples like E naught of, like they will mention which are the following is strong reducing agent, like lithium option A, and B is magnesium, and C is potassium, D is aluminum. Like this they will mention 4 options. Arrange the following in their reducing power or reducing agent nature. So which is strong reducing agent? See, which is having more negative reduction. See, these are reduction potential values, no? Which is having more negative reduction potential value? Lithium, no? So lithium is strong reducing agent. So you can remember the word in this way. More negative reduction potential value can be considered strong reducing agent, or more negative reduction potential value is nothing but more positive oxidation potential value. Okay, because both of them are having same value with opposite signs. Okay, that's why I am saying either more negative reduction potential value or more positive oxidation potential value. It means same value with a positive sign. Then that can be considered strong reducing agent. First lithium, after that if you observe, next potassium we have, after that we have magnesium, then aluminum. So you can write lithium, next potassium, then next magnesium, and least is here aluminum. Okay, like this you need to write the order. Okay, hope the discussion is clear. If this is clear, please mention clear in the chat box. Yeah. Now look at here, we have few more examples to be understood. Look at this, all the examples. See, at the top of this table, this is continuation to the previous one. So we are coming from bottom to top. So at the top of this table, you are seeing the reduction potential value is highest for fluorine. Okay, so conversion of fluorine to fluoride ion is very easy. It means this species fluorine will undergo reduction easily and oxidizes others. Okay, what I am saying, fluorine will undergo reduction easily and oxidizes others. Since it is undergoing reduction and oxidizing others now, so we can say this is an agent which helps others to undergo oxidation easily, right now. So you can say it as an oxidizing agent. So which is strong oxidizing agent? The one which is having more positive reduction potential value. The one which is having more tendency to undergo reduction will act as a strong oxidizing agent. So our fluorine is strongest oxidizing agent from this table. Okay, now they will give 4 options, which are the like arrange the following in the oxidizing nature. Okay, how do you do this? So just you need to look at these values. So now they won't even mention values. Now what you need to do? You need to remember the orders. Values no issues, just you need to remember the order. So just what to do here, I will tell you one simple way to remember. See, you started from here, you just read it very fast, like likna ba, like that, likna ba sarkana mag almanjan, like that. You just keep on reading it fast. You will get all the alkali metals first, the next alkaline earth metals, the next aluminum, that 13th group, like that. It will goes on, and it will be reaches P block, that is halogens at the top. Okay, so it means what you are getting, metals like metals, alkaline earth metals have more positive nature now, so those can act as a strong reducing nature. They show more reducing nature character, and non-metals here show oxidizing nature. Okay, so here they will show oxidizing nature. It means they will be in negative forms, non-metals will be in negative forms, metals will be in positive forms. Okay, so they have more standard oxidation potential, and these non-metals have more standard reduction potential. Remember this. Okay, so out of this complete table, which is strongest oxidizing agent? Fluorine. Out of this table, complete table, which is strongest reducing agent? Lithium. Okay, remember these 2 terms. Okay, strong oxidizing and strong reducing. Okay, that's it. Hope complete discussion of this table is clear. Now they will be giving you few questions. like this. See, now you just have seen this one, E naught of Zn to Zn plus 2 to Zn is Zn plus 2 to Zn is reduction potential now. So this reduction potential is minus 0.76 volt. Then next, E naught of Cu plus 2 to Cu is equals to plus 0.34 volt. Okay, then E naught of this cell, they will ask like this, E naught of this cell is how much they will mention. So how do you do this? Just give a try from your side. Yes, anyone can answer. If you know the answer in the chat box, please mention it. Yeah. So what is this value? Tell me. See, we know for a spontaneous process, like just now we discussed Zn plus Cu plus 2 converts into Zn plus 2 plus Cu right now. So now what is this values here? So E naught of cell of this thing, I have mentioned like zinc is converting into zinc plus 2 ion. So E naught of Zn to Zn plus 2 plus E naught of Cu plus 2 to Cu. Okay, then what you will do here? So what are the values mentioned? So this conversion of zinc to zinc plus 2 ion is, see, this is a reduction potential. Here I have written oxidation potential right now. So oxidation reduction potential have opposite signs. So you just take positive 0.76 plus, what about this value mentioned? This is reduction potential only mentioned, that is 0.34. Okay, so that you will get 1.1 volt. This is what? E naught cell. Okay, this is your E naught cell. Okay, just remember this. Okay, hope everything whatever we discussed here is clear. Yes guys, if this is clear, please mention clear in the chat box. Right, let us discuss few more things here. We will be giving you one question. Tell me what will be your answer for this cell. See, the half cell reactions with the reduction potentials are given like this. Then calculate its EMF. See, how do you do this? For both of them, reduction potential values are given. So which is having more reduction potential here? See, this value is more reduction potential now, so it will undergo reduction and the other one will undergo oxidation. Okay, see, reduction potential value is given here as a positive. So more the reduction potential value, consider that will be undergoes reduction at cathode. What happened? That will undergo reduction at cathode. The remaining electrode, remaining half cell will undergo oxidation at anode. Therefore, you can say E naught cell will be equals to E naught of oxidation, like where it is taking oxidation is taking place at anode now. So in the previous case, you have written Zn converting into Zn plus 2 plus E naught of Cu plus 2 is converting into Cu. So this process oxidation happens at anode now. So E naught of anode plus E naught of cathode you are writing. So this is oxidation potential, but during the exam, see, both of them are given as reduction potential values only. So wherever we have anode, that potential I can write it as minus of E naught of anode. So previously I have spoken with respect to oxidation potential. Now I am converting into reduction potential. So by default you just consider that if they mention E naught, so this is a symbol for indication of standard reduction potential. This is not for oxidation. Even if and only if they mention it as oxidation potential or symbol is mentioned like this for the given electrode, then you consider it as oxidation potential. If they simply mention E naught value, then you can consider it as a standard reduction potential value. So here I am writing this as minus of E naught A plus E naught C. So what is this? Both values are reduction potentials only. So E naught reduction potential of cathode minus minus of E naught minus E naught potential of anode. Okay, so previously I told this is an oxidation potential, this is a reduction potential. Now both of them are reduction potentials only. So this I can say reduction, E naught reduction, this is also E naught reduction. See, I am writing this as it is, but here I have previously written oxidation, now I am writing reduction. Okay, I just wanted to give a standard set of formulas, okay, so that you will remember. So first formula you can remember in this standard form. Okay, so whenever you have both of them as reduction potentials only, you just take E naught cell is equals to E naught cathode minus E naught anode. Okay, so now which one is considered as a cathode? The one which is having more reduction potential is considered as cathode. So here it is 0.8. Okay, minus, what about this? Minus of minus 0.13. Okay, that's it. This is at anode. So totally you are going to get a positive value here, positive. So it will be 309. So 0.93. So how much E naught of the cell? E naught of the cell is 0.93 volt. So this is how you need to calculate the things. Okay, is this clear, guys? Yes, if it is clear, please mention. If you have any doubts, you can ask me in the chat box now. Yes, anyone who is having doubts can mention. If no doubts, I will be writing few questions of EAPCET. Just mention this. How do you calculate? This is a EAPCET question. So question says E naught of cerium plus 4 to cerium plus 3 is given as 1.6 volt, and E naught of Fe plus 3 to Fe plus 2 is 0.76 volt. Okay, then E naught of like this they have mentioned, E naught of Fe plus 3 oxidizing cerium plus 3 is dash. So how do you do this? No options required. You can try this and just tell me how do we do this. See, Fe plus 3 is oxidizing cerium plus 3 now. So it means Fe plus 3 undergoing reduction and cerium plus 3 is undergoing oxidation. Okay, so it means cerium plus 3 converting into its oxidized form, that is Ce plus 4. This is Ce, not Ce plus 4, and Fe is undergoing reduction from Fe to Fe3 to Fe2. Okay, like this you can mention. Now tell me what you can make here. E naught cell is equals to E naught of Fe plus 3 to Fe plus 2. Okay, this is reduction. Okay, plus E naught of cerium plus 3 to cerium plus 4. Okay, if you write in this way, right. So what are the things they have mentioned? So from plus 3 to plus 2, how much? 0.76 volt. This is at cathode. Now at anode they have mentioned in this manner. I am writing in this manner, but they have given in the reverse. So you can take minus, this is oxidation potential, this is reduction. So you can write minus 1.6. So that you will get 1.6 minus 0.76 volt. Okay, so this will be how much? So it will be around 4, that will be around Z plus 0.84 volt. Yes, this is the value you will get here. Okay, so here we have option A in the 4 options. So this is what the EAPCET asked, like previously asked EAPCET question. Okay, so for your practice purpose, I just wanted to show you few more questions. Tell me, so just tell me, given that E naught values for lithium, zinc, H2, mercury, silver are given in this way, which are the following has highest reducing capacity, which is strongest reducing agent out of these 4 options. So we know strongest reducing agent is lithium. Why lithium? Because it has more negative reduction potential or more positive oxidation potential right now. So here see the more negative reduction potential, it means it has more positive oxidation potential, it means it has high tendency to undergo oxidation and reduce others. So lithium first, after lithium compare zinc and other things. So zinc is negative, hydrogen is 0, it means after that zinc, and after that hydrogen, and least is silver, because silver is having positive reduction potential, and it means it will have tendency to undergo reduction, and oxidation potential is negative, so it means it should be least here. So Ag here, least. So this is the order you can mention, but as per their question you just take 4th option is your answer for the question. Okay, hope this discussion is also clear. Can you solve this question? Can you solve this question? What they are saying, very easy. Can a solution of copper sulfate be stored in a vessel of nickel metal or not? Can we store this copper sulfate solution in nickel vessel or not, they are asking. Okay, so how do you answer this? Just tell me based on your understanding whether it is possible to store copper sulfate solution in vessel, nickel vessel or not. Okay, by looking at the reduction potentials you need to answer this question. Okay, it's very easy, please try and tell me your answer in the chat box. Okay, next, here one more question is for you. Which of the following is not possible? Which of the following reaction is not possible? How do you answer this? Very easy it is also. How do you answer? But the table I have given now, electrochemical series table. So based on from that you can see their reduction potential values, reduction and oxidation potential. Which of the following reaction is not possible? So just check which one, whether hydrogen is at which side. See, we have seen like this, we have seen this side you have copper, like this you have elements like this we have. Okay, so now from this, the one which is before this hydrogen, this is hydrogen. Okay, one which is before this hydrogen, all these metals are there now. So these are electropositive, these are strong reducing agents. What we know, these are reducing agent. So as we move from here to here, reducing nature decreases. Okay, so it means they will be in positive form. Which one? This lithium, these things. Okay, so this will be in positive forms when we look for the hydrogen. Okay, so now here it is 0. When I compare with iron, here iron it is. Okay, so yes, iron has ability to convert H plus ion to H2. Yes, this is possible. Okay, because this is iron is before hydrogen now. Yes, the species which are before hydrogen can liberate hydrogen from their acids. Okay, right. Whereas copper, if you see, copper is here and silver is here. Okay, so yeah, between copper and silver, yes, so copper can exist in positive nature, like positive +2 when we compare with the silver. Yes, you can compare with these two things. So which is this side, so that will be exist in positive form. Okay, it means they can be in oxidized form. The other one which is this side at the bottom of this line will be in neutral form or in neutral form. These are at the top will be in positive form, at the bottom it will be neutral form. Okay, it means these are in reduced forms, these are in oxidized forms, like that you can remember. Okay, yes, this is also possible. Next, KBr and I2. So if you compare with Br minus and I minus, just remember their electronegativities. So fluorine F2 has more oxidizing nature, the next chlorine, then next Br2, and least is for I2. Okay, it means out of these statements, see bromine, like a bromide ion is there now, so bromide ion only stays, like bromine only stays in bromide ion form when we compare with I2. Okay, therefore this reaction is not possible, this third reaction is not possible. Okay, and now look at this reaction, copper oxide is there, this is +2 and converting into copper. Yes, this is possible because see hydrogen is first, so hydrogen will be in +1 form and copper +2 is converting into copper atom. Okay, so based on these values, I mean this order, you can give this this type of answer. So option 3 will be your answer for the question. So if you want to get more clarity on this, let me give you one more reaction here. See, I am writing NaF plus Cl2. Okay, this will be written as NaCl plus F2. NaCl plus F2. Okay. Okay, like this I am writing. This is option A. Option B I am writing NaCl is there plus F minus we have 2F minus. So that F2 we have. So here I am writing NaF plus 2NaF plus Cl2. Out of this A and B, which reaction is possible, they will ask. We know which is strong oxidizing agent between fluorine and chlorine. So fluorine is strong oxidizing agent now. So fluorine will oxidizes chloride ions but not reverse. Fluorine is oxidizing chloride ions but not fluorine is, see here fluorine oxidizing chloride ion to respect to chlorine gas, but reverse is not possible, that is not a spontaneous, because fluoride ions, like fluorine always exist in its fluoride forms like F minus, because their oxidation, like if you see the reduction potential value is greater for highest for fluorine, that's why we are saying it is a strong oxidizing agent. That's why fluorine will be in F minus form, and the reverse one, if I take F minus to F2 conversion, this is not a feasible, not a spontaneous. So only B reaction is perfect, A is incorrect. Which of the following reaction is not possible, they will ask like this. They will give 4 options and they will ask. Let me give you one question in the same manner. See, I am writing here NaCl plus Br2 gives rise to NaBr plus Cl2, and NaCl plus I2 gives rise to NaI plus Cl2. Okay, and the next NaI plus Br2 gives rise to NaBr plus I2. Okay, so now I will be giving you these questions, just practice it and tell me. I know you can able to answer based on the discussion, so but I am expecting the answers for these questions in your in this chat box. Just give me your answer in the chat box. If it is not clear, even if it is wrong, no issues, I will explain based on your answer. Okay, here I am writing NaCl plus Br2. Okay, okay. Out of these 4 options, A, B, C, D, 4 options I have given. Out of these 4 options, which one is spontaneous, which one is non-spontaneous? It is a multi-selective type question. It means more than one answer may also be correct. Okay, you just tell me which of the following is feasible reaction based on your understanding. Okay, which of the following is possible or feasible. Okay, possible reactions. Okay, possible reactions are spontaneous reactions from the following. Spontaneous reactions from the following. Just mention your answer in the chat box. Okay, right. Next one. Can you answer me based on like which of the following is strongest oxidizing agent? How do you answer this? Look at their values here. See, all of them are reduction potential values only. So all of them are reduction potential values. So all reduction potential values means, so if more reduction potential value, it is a strong oxidizing agent. Okay, so if more reduction potential value, it is a good oxidizing agent. Out of these 4, which is having more reduction potential? Yes, here if you see 1.52, so it can be a strong oxidizing agent. It will oxidizes others and reduces itself. That's why its reduction potential value is more. So more reduction potential value means it has tendency to undergo reduction and oxidize others. So 3, and after that 3, just look at the other options also. first 3, the next 1 and the next 4 and least is 2. So this is how you need to mention your answer in the exam. Okay, is this clear guys? If this is clear, please mention clear in the chat box. Okay, so this is about the discussion. Now let me give you a few more questions. Yeah, so guys, take this question and just tell me your answer for this one in the chat box. Okay, so this is about the discussion. If you have any confusions, please mention. If there is no confusion, yes, practice this and tell me your answer in the chat box. Yes. Chunky Ponde, hi dear. Yeah. Yes, if there is no doubts here, yes, please mention whatever the questions I have given as homework, please mention answer for those questions without neglecting them. Okay, so thanks for watching. Stay connected with this NEET World YouTube channel, and if you have any doubts, write in the chat box, and you can share these sessions with your friends who are preparing for NEET, JEE and EAPCET exams. Okay, so thanks for watching. Stay connected. Thank you.